Let's learn a little bit more how we can use inheritance to create some common parental generic properties that can be inherited by a whole bunch of more specific children. This is a really useful skill to develop. It's used all over in object-oriented programming. It's kind of at the core of why object-oriented programming exists in the first place. This idea of having more generic, bigger picture, broader parents that then you can borrow functionality from, and a whole diverse array of subclasses that can borrow that functionality. So I've pre-built just some empty classes here, a car, a helicopter, and a motorcycle, which are all going to end up being inheriting from this vehicle class. And I've just built an empty constructor. Might insert something in there a little bit later, but for now, I want to show you really quick creating a couple of class variables and then how to generate some getters and setters for them. So for this generic vehicle class, I just want to create a few variables that hold information that's generically about vehicles. So maybe I have public int num wheels, the number of wheels this vehicle has. Maybe I have another int the max number of passengers that vehicle can hold. And maybe I have a public float, in this case, for the fuel capacity, because all these vehicles maybe run on fuel. Let's assume no electric ones here, but the fuel capacity that we'll keep track of. And maybe one more, a public boolean for is on, or maybe I'll say turned on, whether or not the vehicle is turned on or not. Maybe we have a simulation or something to know if it's turned on. So we want to know how many wheels, passengers, the fuel capacity, and whether or not it's turned on. And I want to be able to give these variables getters and setters, because what we want to really do in Java is have everything as a variable be private, even when things are being inherited. It just keeps things tidier and allows for more secure access to things. And I could make a bunch of these automatically really quickly, but if I press Alt Insert, I can generate, well, a constructor. I'll show you this really quick. Alt Insert, I can generate the constructor for this, and for the vehicle, just hit generate and it'll pop up for the vehicle. But Alt Insert, I can also choose getters and setters. If I choose this, I can just go select all for the 4 different variables, and if I press generate, it will automatically create these getters and setters. Get num wheels and set num wheels, get passenger set, get fuel set, and check if is turned on, or set if is turned on. Wonderful. So I have all this functionality really quickly built into this parent class. However, a vehicle itself is not something that I can actually derive. And so something that I'm going to do in this class here is actually, when I create this vehicle, I'm going to set the num wheels to be equal to 0, and the max passengers to be equal to 0, and the fuel capacity to equal 0.0, and turned on to be equal to, I guess it's a float here, so I've got to put in an F, and turned on to be equal to false. And so, actually, I guess I've been using doubles a lot more. So let's just use a double, keep it a little bit more simple for this. And I'm just going to instantiate that this vehicle isn't able to do anything because it's just a generic vehicle that's being created here. And did I change something with the fuel capacity? Oh, yeah, this needs to change now too, because I changed my mind on the data type. No problem. So what is it that I'm going to do with this vehicle class that's not really that useful? It's just kind of a generic placeholder for the concept of a vehicle and the properties of this concept that I'm most interested in this program. Well, I'm going to allow these classes down below to inherit from my vehicle class. Now, all 3 of these classes are technically vehicles. And you know what? Let's use the constructor here just to say a little message. Vehicle of some kind has been created generically. But I'm also going to go into each of these classes, and let's just auto-generate a constructor. And in this car, I'm going to say this one is a car. And maybe in my helicopter class, let's do this again, auto-generate a constructor, and say this one, is a helicopter. And finally, in my motorcycle, auto-insert, let's build this. This one is a motorcycle. Great. Now if I go into my runner, I can instantiate these 3 different vehicles. Car equals new car, and helicopter. I'm going to call it a heli equals new helicopter. And did I spell it wrong? I spelled it with an O in there. So let's just stick with my typo. And let's go to motorcycle. Moto equals new motorcycle. Wonderful. Now if I create each of these, let's run my code and allow these to be generated. And we see this building here. A vehicle has been created. This one's a car. Another one has been created, and it's a helicopter. And another one has been created, and this one is a motorcycle. So we can see that the inheritance is working. All three are still building the content of vehicle when they're created, but they also have their own unique code running because they are implementing their own code alongside the inherited code. But we want to do something a little bit more involved here, which is we actually want to allow our vehicle to kind of set up these different parameters, each of our vehicles to set up the different parameters in place when I create them. So what I'm actually going to do here is ask my vehicle to require some information when things are created. So rather than just setting it to 0 right off the bat, I'm going to actually set a second overriding constructor. So if I just make a vehicle straight up, then it's not going to have any values set up to it. There's other ways of enforcing that you can't even make it in the first place, but we'll deal with that in a future lesson perhaps. I'm going to make a different vehicle constructor that overrides or provides an overload, a different option for the constructor here that requires 4 pieces of information. The num of wheels, I'm going to call it numw, an int for the num_p for passengers, a double for fuel capacity, and a boolean for turned on. And I'm going to set my variables to these values. Num passengers, and my fuel capacity equals FC, and my turned on state is going to equal to T on. And I have oh, that was confusing for some reason. I have all these getters and setters that will allow me to change these things later, but I just want to set their initial states when these objects are created in the first place. In fact, maybe I won't even include this one because I might turn it on later in the program. It's not going to start turned on. I'm just going to set the initial conditions of some of these things. Now, if I save this and head over to my other classes, these are still working just fine because I provided an option for the vehicles to start with nothing set for them, but also for them to have some custom variables assigned. I have an optional constructor. So really what I want to have happen here is actually have some information sent to the parent class when these are created. So I'm actually going to go to my vehicle and I'm going to copy this information because I want this to be sent into my car when I create it, and to my helicopter when I create it, and my motorcycle when I create it. And what I want these to do is to actually send these to a constructor, numw, nump, and fc. Maybe I should give these better names, but the supercall must be the first thing in the constructor. I forgot I had this system call here. What this is going to do is when the car is instantiated, it's going to send its parent, the vehicle, this information to set up all of the parameters in the way that we want them in the first place. So here's the car set up, and now I'm just going to copy and paste all of this because it should be the same in each of these. Let's hit enter and paste this here, and motorcycle, and let's paste this here. So now we have the ability for each of these things being created to have to come prepackaged with some information. So what is it that I need in the first place here? Well, I first need I need an int, and a double. The first thing was actually the number of wheels, so this is going to be 4. The number of passengers, let's say that's 5, and the fuel capacity, I don't know, let's say it's like 45 for like 45 liters. And a helicopter, how many wheels does it have? Well, technically, I guess maybe you can count it as maybe having 2, or I guess since they're lined up, depends on the helicopter. Let's just say this one has, let me think here, 3 wheels, because it has a back one that it has to kind of land on. Yeah, let's think a bit better. And the helicopter, maybe it's a 4-passenger one, and maybe it has a much bigger tank. Let's say 300 for this. And our motorcycle, it only really has room for 2 people. 2 wheels with really room for 2 people, and maybe a much smaller fuel tank, like 20 whatever units that we're looking at here, maybe liters. And so now I'm creating each of these objects to be holding their unique initial state of information. So a car has a different amount of its properties, its parameters, than a helicopter and a motorcycle does. And What we've done to manage this is we didn't actually put any of this information. Let me get rid of some of this extra stuff so that's really clear. In any of these child classes. They're really simple classes just with the constructor. All of the busy work is being done in this vehicle class, which is kind of the blueprint for how a vehicle works. It holds all the information about these different settings, and it also allows us to access and change any of these things later. And because our car, helicopter, and motorcycle extends the vehicle, they have access to all of these variables. They can actually set up their state, and through the different inheriting methods that they have, these ones down below here, we can actually change all this information on them later. For example, what if let's say I got a car, and then in this program, decided that it always has to have some kind of a cool, I don't know, setup inside of it that's going to eat up the middle back seat. So I actually want to go, hey car, actually in this case, the number of passengers that you can carry is actually only 4. So I need to change that about you to update with some information that's going on here. And maybe my motorcycle, I am very picky and I only want you to actually have the one driver. That's something that I'm limited to. But the heli, maybe there's an emergency that's happened and your max passengers, I'm bumping up to 6. We're cramming more people in there because we need to carry some people off. And I also have the ability to say, hey car, are you actually turned on? And I'm going to turn you on. And I'm going to turn the heli on as well. Don't take that the wrong way. And I'm going to turn both of these things on at a different part of my program. And all of this, the actual variables for heli and car that are unique to them are going to be turned to true, but there's none of those variables are in these classes. They're all being inherited from vehicle. Meaning that if I want to change the way any of this works for all 3 of these classes, I change it just one time in the vehicle. For example, what if I want the fuel capacity to not be able to be changed? Like, that's locked in place. I'm not going to be replacing the fuel access in any way. So let's remove the ability to ever change the fuel. So in my runner here, now this is mad at me. What did I do with the helicopter? Why is this getting mad at me? The fuel capacity. Oh, this. It should be fine because I'm setting it to the variable, so that should be good still. It just got a bit confused. That's all right. Now I'm actually not able to change for any of these, if I go to my runner here, for any of these vehicles, like the car, the fuel capacity is no longer settable. It's only gettable. If I hadn't used inheritance, I would have to go through and delete that method from each of these classes. But because of inheritance, if I delete it in the parent class, all of the children lose access. In a similar way, what if I wanted to, later down the line of my program, I realized like, oh, these vehicles, I'd really like to have information about, I don't know, maybe the value of the vehicle. And so now I want to actually insert another, I just want to be able to maybe get and set the value. I'm going to generate a getter and setter for the value. I kind of generate it in an awkward spot. I'm going to move it to the bottom here, just so it's a bit more organized. So I'm able to actually change the value of these things. I've only added it to the vehicle, only the parent. Nothing has been done with the children. But if I go to my runner and I go, you know what, this motorcycle, I'm going to set the value of this motorcycle to $30,000. Bam, I have a value set. I can do the same thing with the car, set the value. I can do the same thing with the helicopter. Those inherited methods are now useful by everything. I can consider taking this to the next level even, where I have a car, but what if I have different types of cars, right? What if I wanted to create like a specific brand or a specific model of a car? I don't know. What about a Lambo, just in short? And maybe I had another one that was just like a Prius. So clearly there's going to be some differences between the Lambo and the Prius that I might want to keep track of. Maybe things like their value, maybe things like the number of passengers, maybe things like their maximum speeds that I could consider. In car, maybe defining some of these things that aren't relevant, that I don't care about for all vehicles, but maybe in car, I actually do suddenly care about, I don't know, trunk space. And let's make this, I don't know, just an int for some kind of a value, maybe square feet or something of trunk space. And maybe I have one more thing for the num cup holders. Maybe I care about this for some reason. I can put this in the car class, and now I can make the Lambo extend car, And my Prius, well, now I need to actually send it information about the constructor that needs to be passed on because of the way I built it, but that's okay. We can deal with that if we ever wanted to do this. I can have this extend car as well. And now these classes are going to be inheriting all of this information, which also still inherits vehicles. So the Lambo and the Prius are still going to be able to have all this information set for them, as well as the new custom information. Just to be really clear, let's generate some getters and setters for these as well. I'm going to be able to work with trunk space and cup holders for the cars as well, because I've built that into this new inheritance structure. And you can build as many layers of this as you want, as long as you can kind of keep track of things and make sure things function properly as you go through. Notice that, well, just know, I suppose, that because I implemented this new functionality in the car class, the helicopter won't have any access to it or interaction with it, and neither will the motorcycle, because they only inherit from vehicle. They have nothing to do with the car. So now this is functionality that's wholly separate from the other vehicles, that's just specific to the car type vehicles, of which my Lambo and Prius are. Hopefully, that's given you a bit of a clear sense of how inheritance works and how we might be able to use it to kind of save ourselves some work and also organize things conceptually in our work while we're writing things in Java.